Okay. And you guys are still seeing my screen, right? It should be a PDF document. It's a study guide. Okay. Is it big enough?
Don't ask me. I'm in my gazebo.
Okay.
Greenhouse.
All right. So, all right, lens meridians, where we're at. Yeah, so your boxing system of measurement, lens centration, vertical and horizontal. So that's the PDs and frame PDs and figuring out how much to move that lens to get it to center in front of the patient's eye, horizontally and vertically. And then to do that, of course, you need to know your patient reference points for lens styles. So where do you fit? I think we've gone over those a significant amount. So where do you fit those? Um, the OC, where do you fit progressive? Where do you fit aligned bifocal, particularly a flat top 28, flat top 35 or something like that. So recognition of what those lenses are and where to fit them for the patient reference point. Remember the trifocals are 7 by 28, and the breakdown for those as well. You know that the 28 in a flat top 28 means that it is a 28 width at its widest point, and that's how we measure that. Understanding that boxing system, there was one thing that I wanted to show you guys from the last one. 1 second, let me pull up some pictures. There was the frames. No, oh, there it is. All right, this right here, I wanted to point out with the boxing system of measurement, a couple of things. When we're doing decentration, we are moving, like we were talking about in the last class, but we're moving from here. If we don't do any decentration, we start out at these points. So whatever the frame PD measures, that that is going to be where we would be when we start out with decentration before we do any decentration. And then you have the patient's eye in at some point in the frame, and you need to move the lens major reference point from the boxing center to the patient's eye. And this horizontal movement here is considered that decentration amount. And then we have also, we could go horizontally or we could go vertically. And when y'all are measuring, when you're measuring to get the PD, the frame PD in actuality, you always hear this, that you can measure the A plus the DBL, right? You know, A plus DBL for decentration formulations, right? That gives us our frame PD. But what that measurement actually is, okay, so here's this line goes right here, right? So it's the same as when you're measuring one of the A's. So 1A plus the DBL, or from the other side, the A plus the the A plus the DBL over here. But ultimately, what we're trying to find is where this boxing center is in reality, like, because you don't have the opportunity to sit down and box this frame out and really find where that boxing center is, and then take and measure that on each of the lenses. You just don't. So this A plus the DBL helps you figure that out. But the main point that we're coming from is right there at the boxing center. So all the decentration. So whenever you get those questions that say the decentration is 2 millimeters less than what it should have been, what it should have been is wherever the eye is. So it's 2 millimeters less than what it should have been. That kind of thing. Let's see what else was for the boxing system. And the vertical, I think everybody seems to understand that the vertical, this midline height, this is also where we start that starting point for decentration vertically. So if the eye is positioned up, then we need to move up. And if the eye is positioned down, we move down. When we make a movement up, that's a positive. And when we make a movement in, that's a positive. Whenever we go down below the midline, we consider that a negative value. And if we go out from the midline, we consider that a negative. It's the same thing that happens over here, but it changes. It's in, so this is in, so this becomes positive, out becomes negative, up would be a positive value, and down would be a negative value. So the way I always thought about it was it's good to be up and in. So anything up in this quadrant, in and up, is always going to be a good thing. Anything that's down, and especially if it's out, is bad. So when, I don't know, maybe that'll help you. That's when you're doing those decentration calculations and you get that negative value. Y'all remember the formulas for decentration, right? Mm-hmm. The frame PD,
Yes.
A plus the DBL, minus binocular PD. And then the same version, just another version of that is divide that in half, and you can use monocular PD for that. So these are both horizontal decentrations. Then when it comes to your vertical, you have, well, before we do that, remember also that the PD that you need is associated with the lens that you're trying to use. So we have single vision lenses and we have distance PD, or a distance pair of glasses. Then we want to use, of course, the distance PD, right? If you're doing a reading pair, then you need to make sure you're using the near PD. What PD do we use for segments? The distance or the near? Or both?
Near.
Yeah, we kind of use both distance and near. The lens is set out, like laid out based off of the near. So really the near PD is what we need for our decentration purposes. But yeah, the near PD for that one. But you could also take that distance PD as well. And progressives, distance or near PD?
Distance.
All right, so yeah. keeping up with what your lens is, that's what's going to help you when you do the decentration and interpreting those, what you're given versus what you're being asked to do. And patient reference points. When we're doing for vertical, the vertical formula is the height of the lens, whatever that eye height is, minus half the B or the midline equals our vertical decentration. And so where do we take a height for a seg flat top 28? We take that at the lower limbal, right? Lower limbal, lower lash line. All right, and flat top 7/28, which would be a trifocal. We take that at the lower pupil margin, right?
Pupil -1.
-1 for that clearance. And then a progressive, where do we take a progressive?
Dead center.
Dead center, pupil center. Very good. All right, good, 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 good. What kind of PD do we use for a progressive? Monocular or binocular?
Monocular.
Monocular. Distance or near?
Distant.
Nice. All right. Kind of the same thing, like ditto, we'll say. Ditto for single visions, but what about seg? Well, we did seg, didn't we? What about the PDs for segs? That one was that near PD. We did that already. So near PD for anything that's a segment. All right, good. When it comes to the module 3, the manufacturing and safety, I'm not going to switch back to that document. I should have maybe just had it up here. Yeah, but when it comes to for module 3, the manufacturing and safety, order of operations is going to be kind of very similar to the ones that you've had, and just kind of knowing what the different, the surfacing lab versus the finishing lab and the terminology associated with that, what a finished lens is, what surface semi-finished lens is, uncut, a lot of those terms that we've been going over this semester. Yeah, and knowing that it might be a good idea to go back in and watch the video of kind of the overview of the surfacing and finishing process so you can kind of, again, try to associate those individual names, titles. So, selecting the lens blank and then lay out and block it, um, generate it, fine and polish it, all those. So just be familiar with those. When it comes to the safety organizations and their purposes, these are kind of the big ones that you need to know that, OSHA is associated with workplace safety. ANSI is that standard setting agency. The FDA is important because it's the one that mandates the impact resistance of lenses.
Yep.
I'm gonna share my screen here. Is that sharing or not?
Don't see anything.
Okay, hold on, y'all. Share. Okay. All right. So yeah, I'm right here with OSHA, ANSI, FTC, the Federal Trade Commission, and that they do that eyeglass rule. I don't think we talked a whole lot about that. I was in the safety worksheet that you did for 131, But that the FTC, the reason, they're the ones who established the eyeglass or prescription release rule, the eyeglasses rule that states, that we have to make sure that when someone does an eye exam, that they're given a copy of their prescription, without asking for it or any of that. So that's kind of the importance of that. The SDS, that's the safety data sheet that holds all the information about any chemicals that you work with, um, so that you know how to respond in any kind of given situation that might happen. Because remember, labels don't list everything. So that SDS does, and it will list, the way you respond to situations, and what kind of harshness of the chemical and what kind of long-term effects, different things like that. When it comes to the module 4 for the lensometry, understanding those general parts and the uses, that PowerPoint would be a good place to kind of go back to. You should have some good familiarity with the lensometer, just knowing where the power drum is, the what the frame table is, what it does, why it's important, the axis wheel, focus in the eyepiece. You guys remember how much error caused it could be caused by an eyepiece that has not been focused? Up to how many diopters of power error? Yep, a quarter. Yep. Um, yeah, and the interior target. So we're going to look at a little bit of that too. Um, let's see, interpretate, doing the power drum reading. So very similar. You're going to see the power drum reading, like a picture of the power drum, and then the first reading and the second reading. And remember, the first reading on the power drum is always the sphere. You need to be focused in the sphere and take that first reading, and that'll determine your sphere power. And the axis wheel will tell you your axis. Then you rotate the drum some more until your cylinder lines are in focus. And the prescription is the difference between those two powers. That's the value. Add power, that is kind of covered, or it's covered in the module for segments. I think module 10 here, where I didn't finish, had placeholders. But your yeah, figuring out your add power. Let's just move that here. And basically all that is when you're in the sphere in the distance, when you're reading above the seg in the distance and you're focusing that power, that you focus the sphere, get that sharp, and then move into the seg, center that in the lensometer. What else? Just put the seg over top of the lens stop, and move the drum in a plus direction because it's plus power, add power. Move it in a plus direction until you reach the sphere power again, until the sphere focuses again. Because when you move into the seg, it's gonna get blurry. So what your distance power will then look blurry. And the distance from the sphere in the distance to the sphere in the near is your add power value. Prism displayed in the target. Let's do it now. You didn't lose sound, Greg. I'm trying to switch devices.
I was thinking I did.
Okay, so this is the interior target of the lens meter, and you remember all the different parts that was in here, right? You've got your circle reticles here, so that's what this is pointing to. You've got your prism reticles, and the very center of here, you guys are normally focusing your um, lensometer target right here, where you've got your sphere and your cylinder lines are crossing right at the center. And at this point, we have 0 diopters of prism. Well, these circles here, all around, are showing progressive amounts of prism. So 1 diopter of prism, 2 diopters of prism, 3 diopters of prism, 4, and 5. Goes the same way down the other way as well. 4, 5, and out this way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Whenever you move away from the center of this target, whenever you move this away from the center of that target, you are inducing some amount of prism. Okay, so right here, when we're centered at the very center of the target, and just to refresh your memory, remember there's the sphere line or the cylinder lines and then the sphere lines. So the 3 little thin lines, those are the sphere lines, and the 3 thick ones, those are the cylinder lines. But most importantly, the very, very, very center crossing point of those is the point that we're referencing at all times. We're referencing the very, very center of where that's at. And the reason that point is so small is because this is going to help you to make sure that you can do the or measure how much prism you're seeing displayed. So if we move up from here straight up on this line, let me go back and just, we also have this little scale here going. You see this one in the background, right? And you see we got 0 up to 90 over to 180. You can move this prism line, and you can move it and spin it around. That's by using that chrome knurled. I don't know if I have a picture of the lens meter. The chrome knurled sleeve up near the eyepiece. You can move this around to the different positions. But for these, we're just going to keep them in the 90, moving up and down. So vertical meridian, 90 prism, up and down, or on the 180, in and out prism. Okay, so there's base in, base out, base up, base down. When you're looking at this, the center of the target, you can always think that the center of the target is where the patient's eye is. So right here, and that's where their eye is. Wherever this prism target or the power lines are positioned, wherever they're positioned on the target is equal to that amount of prism. Okay, so let's just do the simple one is straightforward. If I move this up and it's positioned right here and I spot the lens, how much prism is being displayed in the target?
Two diopters.
2 diopters. And what direction is it?
I'm looking upside down. It looks like it's base up.
It is base up. Okay, so how did we get that? How did we get 2 diopters base up? This is the 0 diopter prism point. Okay, and you think about the eye. Oh, one thing I left out that I shouldn't have is that this point right here, wherever this center of this target goes, this line, you can think of this as the base of the prism. That's the big key. You can think of this as the base of the prism. Where this central crossing line is the base of the prism. And so you can see that if the eye is here and the base of the prism is up here, then we are displaying base up prism. That's where Greg got the base up. How much? Where did we get the 2? That was using those prism reticle scales. So we are falling right at the 2, and so we are falling right at 2 diopters base up. All right. And if we wanted, if you see this much in the Lensmeter, okay. First things first, we've gone down below the line or the central point here. So we've gone below this point. We're down here. And so this point is 1 diopter below. So 1 diopter base down. Here's the base. Think of this as the base of the prism, and it's down. Oh, like that. When you go in between, let me do something right here. Okay, so, all right. When you go in between, you see 1 to 2, right? This is a length. Just like it's the same length as this one to this one. So the length from here to here is the same as from here to here. So if you need to be at 1.5, then you would go halfway between this line. So that would be like 1.5 diopters base up. And if you need a half of that, even a quarter, then those are halfway between those, 1.25 base up, 1.75 base up. So it just increases. And then we're up to 2 here, up there at this point. You could break it down even further, though, because what if the target is right in between those two? Then what we're looking for is this point right here. And we're like halfway in between the 125 and the 150. So what dioptric, well, you don't even have to stay in dioptric increments. How much would you say we have? You could probably say, well, I think you have 1.4 or 1.3 or 1.4 diopters of base up prism. All right, so that's how it breaks down in each of those little increments. But I believe in your lessons, you guys got you were doing like compounding amounts, right? Like if it's over here, how much prism? So I'll show you, we'll review that real quick. So, all right, so how much do you, if I'm right, let's say I'm right here. If we're focused and our target's down here, how much prism is being displayed? We're right, this is the point of reference that we're looking at with this. You can tell we're already based down. Right? This guy right here is 4 diopters. This was 5 diopters. We're right halfway in the middle, so 4.5 diopters base down. And so that's our vertical amount of prism. Everybody follow on that one fine?
Yep.
Yep.
All right. Then you have in and out. If you just figure out where's the nose, in and out becomes pretty straightforward. Again, remember that wherever this little line box goes, wherever that target goes, that's the base of the prism. So if this is a right eye, the nose is over here. So the right eye has the nose on the right. Is this, or I'm not using the right one. All right, we're going to go with this. Okay. All right. So for this one, if the eye is stationary, if this target, the power lines are moved to the right for right eye, it is going to create base in prism, because remember, we're looking at center of this line here, this guy right here, is the base of the prism. So when it moves to the right for a right eye, we get whatever amount of prism is displayed. So how much prism would be displayed for this one? We count it the same way. This first ring is a half. We got 1 diopter, 2 diopters, and 3 diopters. So we're somewhere in between 2 diopters and 3 diopters. Right about halfway. So we could say that this one is 2.5 diopters base in.
Yep.
All right. And vice versa, if we are over on this side of the target, let's say we're right here. All right. If we're right here on this side of the target and we're still dealing with a right eye, what base prism is this?
Out. Base out, right?
Yep. So it's base out, and then how much? Where are we at on the target? We're between the 2 and the 3. We're not quite halfway, or we're a little bit beyond halfway. What would you guys say that was?
I don't know, 2.75.
I think that's a great result. 2.75, that's what I would say. Yeah, 2.75 base out. So that's how much prism that one's experiencing. Well, what happens though if it's a right eye, or it's a left eye? The value still stays the same, right? So we still have 1.75. It's still at, or I'm sorry, 2.75. It's still at 2.75, right? But is that base direction still base out?
No, wouldn't it be base in then?
It would be base in, because here's the eye, here's the base of the prism, 2.75, base in. Very good. All right, and then the same thing with this. What if we're here? All right, this is zoom in a little bit. This, I know it looks like the iris, but this is actually the first circle on the Lensmeter target. Okay, it just lined up like that. But this is the half, right? Yeah, so this first circle is a half, so we're right on that first circle. So what do you guys see? A half diopter, right? 0.5. Is it base in or base out? And this is an OS. So the nose is on the left. What do we got?
In?
Base in or base out?
Oh, base out. Okay.
Base out. Okay. Even though it got close, it's, like close to the center there, that's fine. I mean, it could be here, it could be anywhere. Once it reaches this point, once it heads out this way, it's base out. And I want to point out one thing, because my seniors deal with this too. All these extra lines, in all honesty, this one and this one, we just ignore. We don't ever really look at them. Ever. They just kind of throw people off. The absolute only one we're looking at is this one, and the exact point where that one crosses. These other two over here are shouldn't even be there if you ask me. I think it's there for some other types of helpful alignment. But the only point we're looking at is here. So even if some of these other ones, like this one, what might have caused some pause was that you saw this line over here, and so this side's over on the left side, so that's base in, but this side's over here. You don't even look at these. Just ignore these completely. The absolute only one we're looking at is here. And if this is where the eye is, and this is the base of the prism here, and the nose is over here, is base out prism. These other guys, just ignore them. Okay? All right, so let's try another one. What if we're here? What do we got? How much prism if it's a OS? Is it close enough? OS. So look at amount and base direction. I'll take either one.
Two.
Base in.
You guys see it? Base in.
Mm-hmm.
Here's the point we're starting from. And basically we're looking, this is the 0 line. So if the target line, if the green line lines up with this one, and remember, I'm only talking about that very center one. I don't care that there's the green line right here. This green line, I don't, just ignore it completely. This is the 0 point, right? And if we move in this way, it's base in, because for a left eye. If we move this way, it's base out for a left eye. So you see that that this center point right here is base in reference to where the eye is. And then how much is it base in? What's that second circle represent?
1.
Mm-hmm.
So on this, Tracy, it's
Yeah.
you don't have to worry about a minus
Nope.
lens or a positive lens. It's just the direction straight up.
That's what I love about the lensometer. It's straight
Okay.
up. It
Okay.
is what it is. I know that's a cliche, but if you just think of that being the base direction, I don't care what the power of the lens is, you'll just put it where it needs to go. It has no the only part that impacts you is how you actually end up moving the lens, whether you end up moving the lens to the right or to the left, but you're going to be looking in the lensometer. So you're going to just watch to see whatever that the target is doing, because that's what you care about. That's where it's just easy.
Okay.
And so if it's a left eye and it needs to be base in, like this, then it doesn't matter whether it's a plus or a minus, it'll need to be over to the right.
Okay.
And vice versa, same thing with up and down, in and out, all of that. None of that matters. Because you would take care of it when you're literally physically moving the lens around in the target.
Okay.
All right, so let's see. So y'all are feeling okay. So what about that one? What if I'm here and it's an OS? So I would zoom in, make it a little easier for y'all to see. So you can either figure, go ahead. I heard somebody saying something.
2.25.
I like that.
2.1, 2.2.
2.2, 2.25 both sounds great. What about base direction?
BO.
Do you agree, Christy?
Where's your nose?
The nose, we're dealing with an OS. So the nose is going to be over here.
Okay.
Left eye, left nose on the left. Right
Okay.
eye, nose on the right. So 2.25 base out. What would it be if the nose was on the other side. Well,
Base
who
in.
knows? Was over here. Then all of a sudden we get, yeah, 2.25. Value stays the same, but it becomes base in prism.
Okay.
Everybody following that?
Yes.
All
Yes.
right, we're gonna level it up. Oh, let's go right here. Oh no. So okay, now we're doing this is compounding a prism. Before we were dealing with, and does the eye get y'all confused? Because I can take that eye away. It's not on the lensometer anyway. What do you think? Let's take the eye away. All right, let's say we were right here on the target. And we're dealing with a right eye. So nose is over here. All right. Now with this one, this is a compounding amount. So we have two directions of prism, either an up and a down or an in and an, or it's either, sorry. We have up or down and in or out. So just do your base direction first. Just hammer that one out first because we're looking at this point in particular. And my axis is aligned with the 90 and the 180. So you can kind of use those as a nice little straight line that comes right over here and lets us know that we're at the 2 base down. You see that? 2, and we're down. So base down. But then we also have a certain amount in or out, right? So is it in or out? When we look from, yes, it is, right? So when we look from here to here, we see that we moved out from that central point. And so we've got base out here and how much. We can just use this line and go straight up there and see where do we cross the horizontal point. We're looking basically with this one for well, that one, now here we're doing this one for in and out, right? So that was the amount that we went from the center here. So you can see that we went to this point from here, and that would be one diopter. So the way you would see that written is 2 base down and 1 diopter base out. Okay, so let's try. Let's try one. Let's do right here. Okay, so give me the individual components for this one, for the either both the in and out, or the in or the out, and the up and the down, up or down.
2 BI and 1.5 BD.
All right, so 2 base in and 1.5 base down, because we went from here down to here. So we went down, and we're basically going to this line. This is where we're reading it from, right to here. So you see the 1.5 base down. And then we went how far in, and this is the right eye. So base in. What's that? 2. Yep, 2 base in. What if it was here? And let's make it the left eye. So the nose is over here, the left eye. So you can just kind of look at it already and see the base direction. So what do you get for base direction?
Base out.
Mm-hmm. What about is it base up or base down?
Up.
Up.
Base up. All right. And then determine how far out is it? What?
3.
Do not disturb. Share. Are y'all still, oh, okay, I know what's wrong. There we go. Okay. All right, so what'd you guys say for the, which one were we doing? Face up?
Base up is 3.
Mm-hmm. So 3 diopters base up. And what about the base out?
Three.
1, 2, 3.
All right. Do you guys see that? So, all right, good. Yeah, and counting them out, yeah. In real life, you would have the ability to just turn these knobs and move these 1, 2, 3 into this position up here, because remember, that's the line that is movable with that little silver sleeve that's up near your eyepiece. All right, good. What about that one? That one's a little bit further off target. It's getting pretty close to where we need to be, or we need to be using that prism compensating device. So we're going to say this is a OS, so the nose is on the left. And what vertical and horizontal prism do you have? So what's the vertical direction?
Or base up.
4 diopters base up. And what about the in or out? So horizontal.
Or base.
Or base in.
Mm-hmm. All of y'all that are not saying anything and being super quiet, I hope you feel comfortable with these and you're trying to at least do them on your own, even if you're not saying anything out loud. All right. And then some more of the inside here. Let's look at this target here. Inside this first circle right here, remember that one is, well, that first circle here is a half of a diopter circle. Okay. So whenever you're aligned on any one of those, you're at a half of a diopter. The very beginning point of each of these little hash lines actually represents, we're halfway between that center. So this is a half, this is 0. So what do you think this very nub right there at the end is? If this is 0 and this is a half, and right in the middle, what do you think it is?
0.25.
Very good.
Quarter.
And it's a quarter. And so that goes all the way around. These are like circles, okay? But they just don't, it would just get too cumbersome up in here to do that. But you need to still be able to imagine this. And this is an ABO thing as well. But mainly it is in my class. And this is how you use the lensometer. So So they don't mark it, but this first point here is a half of a diopter. So, and just think about it. We're halfway between 0 and a half. So, I'm sorry, I didn't mean a half, the quarter. So this one's at a quarter. And then halfway between these two on these little hash lines, that one is, again, what's halfway between that, the quarter and the 50. We're going to call that one our ANSI tolerance area, right?
Yay.
Okay. All right. So
Yep.
all the way around here is our ANSI tolerance range. I'm going to clean this up real quick. Okay. So here's our 0 point. And basically, all the way out to here in a circle, you're is within a tolerated amount. Okay. Again, because this is that 0 point. So if it's here, if the target, let's just put it there. If the target is aligned right there, and I'm gonna zoom in so you can see it. But if you see that target right there, so what amount of prism are we aligned with? We're aligned right at that halfway. So what are we aligned with, y'all? A third of a diopter prism base up, right?
Yeah.
Okay. What if I'm aligned right here and it's a right eye? So I'm aligned right there.
So
and
it
it's a
is
right eye.
1. It's 1
Somehow.
base out.
So we got a right eye. So the nose is here. So base out was correct because we are out.
One
We're
half.
aligned right here. But you said 1 base out. Base out was correct, but look again, because this first circle here, that's where your 1 is.
It's 0.5. Yeah.
Correct. We're at that very central circle, which is 0.5. So yeah, but you got that base direction right. So 0.5 right there, base out. What if we're right here and it's a right eye? What prism do we have?
We're based
Order B.
down.
0.25.
Yep. I think I heard everybody that was saying it. A quarter base down. Exactly. Very good. And what if we're right there? Bella.
0.33 base in.
Very good. 0.33 base in. That fits a right eye. What happens if it's a left eye? Nose is going to be on the other side of the target, right?
You just
Base
flip
out.
it to base out, right?
Mm-hmm. Because then all of a sudden you see we're the same amount, but we're base out. All right. So that's the ones up close. I do think that for the exam, we don't focus on that quite as much until the beginning of next semester when we get into working with unwanted prism in the lensometer and wanted prism. All right. Here's the other way, though, that you might need to do this is to figure out what y'all were doing. You were reading the amount of prism that's displayed on the target. And I believe that's what you'll be doing on your exam. So you read the amount that's displayed on the target. In real life, a lot of times you need to place it at the point on the target. So you need to be able to look at the prism amount and then place it where it needs to go. So you might have something like a prescription that says, let's do 1 diopter base up, and 2 diopters base out. And let's say it's a right eye. Okay, so the nose is over here. And I need to place this, the green lines, those power lines, at 1 base up and 2 base out. So I need to be able to look at the target and say, well, where do I need to move this? And how do I need to move this? And it's the same way, we're going to go from here and we're going to move to where we want to go. So we want to go 1 diopter base up. So I would go boop, 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 and I land at 1 base up. And then I want to go 2 base out from there. So I want to go, it's a right eye. Which way do I want to go? To the left or to the right?
You want to go left.
Mm-hmm. And I'm going to go out exactly 2. And I'm going to stay on my vertical correct so that I'm still aligned with 1. And I'm going to move out so that I align with the 2. So that's the point of reference. And I'm aligned with the 2. And I'm aligned with the 1. So this is correctly where the target should be, what it should be displaying in order to be exhibiting the amount of prism that I want to be displaying. Okay. So you would do kind of the same thing with, any kind of prism. So let's say we have a left eye. So we got an OS. And I want to have 2 diopters base out and 1.5 base down. So I've got 2 base out and 1.5 base down. So I would just move my lens to exhibit. Am I going to be going out to the right or into the left?
To the right.
Out to the right, right? So I'm going to just head on out here until I get to the 2 line. And then I also have 1.5 base down. So I'm going to go below the line and I'm going to go 1.5. And so the point that you need to be looking at while I'm moving is until we get to here, going down, but still maintain alignment with this. So this line here stays in alignment, and then I meet up with this line down here. So I'm just going to move 1.5 base down. So I'm staying in alignment with the 1 in, and I move 1.5 base down. And then that's my final placement here because it stays in alignment with the 2 base out and in alignment with 1.5 base down. Here's another layer to it is just like when you're applying ANSI, you're told that it needs to be at this. This is where it needs to be. But when you put it in the lensometer, it's not there. It's at a different point. And they're usually just slightly different than where they should be. And so with this one, if you were just reading the amount of prism that is displayed on the target, what do you get? They're going to be slightly different from this, right? Same point here. So let's look, but we're actually falling right about here. So you guys would say that was about what? Here's the 2, 3, and we're falling right about there.
2.25 maybe.
Yeah.
Yeah,
2.2.
2.1, 2.2. Yeah, those, yeah, we're going to go 2.2, 2.2, 2.5. The 5 is fine. You would have still gotten perfectly fine with that one, but 2.2, we'll say 2.2. And then how much far down? So there's my 1, here's my 2, here's about halfway. Probably what, another 2.2? Or I'm sorry, 1.2. Yeah, I fell for it too, y'all. Yeah, we're at the 1. We're just a little bit beyond. So what do you guys say? 1.2 or 1.25? Either one of those would have been perfectly fine. Base down. Okay. So this one was what we got when we read it in the lensometer. This one was what we wanted. So this is like the RX versus the lensometer reading. So how different or how far are we from where we wanted to be? A 2 versus the 0.2, 0.2. 0.2, right?
Yep.
That's how
We're
much we're
within
off.
ANSI.
And we're within ANSI, so that would be perfectly fine. And then the same thing here. I wanted a 1.5 base down, but I got a 1.2 base down. How far am I off?
0.3.
0.3. So I'm off by 0.3. Is that
Which is
within
within
ANSI?
ANSI. Yeah.
So even though what I wanted was this is what I got here. And that's what I read, right? And we applied ANSI and decided, well, those are off by that amount, but they are within ANSI because ANSI allows us how much on that horizontal?
0.67.
Very good. And how much does ANSI allow us in the vertical?
0.33.
0.33. Very good. I would like to point out that we would also need to see what the other lens is, because this one we've applied correctly 100% because we're on vertically, we're only allowed to be off by 0.33. I didn't put the other 3. Let me be consistent. But we're only allowed to be off by the 3.3, but that's in one lens. But remember that with the horizontal, we're allowed to be off a third in each eye. So we're, that 0.67. We'd have to see what the other eye was doing. Very good. So do you guys feel comfortable with, okay, here's where the lens is, how much prism's displayed?
Yeah.
2.5.
What would you get with this one?
1.8
Point-
base up.
1.8 base up.
Mhm.
Good. I like that. And what's
And-
the other?
And 2 base it in.
1.9
2,
basic.
1.9. Yeah.
1.9. I like 1.9 better. 2, especially for what we're doing. Just starting to kind of learn about this. But yeah, you really want to go with that where the very center of this sphere line or that cylinder line is. So we're not exactly at the 2, kind of like we're not exactly at the 2 here either. And for that same reason that I was talking about with ANSI, we need to be able to read these real specifically, because if
you round, you can mess up your numbers.
yeah, 100%. You could round your right out of tolerance, yeah, that kind of thing. Because let's say if it was supposed to be at 1.5, but you're getting here, then the difference between what we want and what we got, if you rounded that up to 2, it'd already be off by a half kind of thing. So we want to try to be as specific as possible. All right, good. So I think, and that's the limit to just, they're gonna be placed somewhere and they'll be in the 90. I think they're in the 90 and 180. Let's throw the other wrench, because not all axes are 90 and 180, right?
Yep.
So sometimes they don't align. And that doesn't change anything really, other than ease of use, maybe, because when they're not aligned, you can't, you have to, let's see, you have to look at them slightly different. It can be a little discombobulating. All right, so you're still doing it the same way. I want to know how far below this line is this point. I'm still using this guy as my down marker, and I'm still using him as my in and out as well. So how far from here is this line? That kind of thing. So what we're essentially doing is with our eyes, drawing a line up to here, and with our eyes, drawing a line over to here to read those values. And this one is where you get slightly different things, especially when you're on the lens. Oh, sorry. Especially when you're in the lensometer actually doing it, because my lines right here, like this one, is not perfectly straight. If I used a cheat like this, and then I line up perfectly. Oh, my Apple Pencil's dying. And I line up perfectly, but we don't have the access to do that in Lensometer.
1.9 base in, 1.4 base down.
Yeah, it looks good.
9 base in. Add, yeah, I like 1.4 base down. Very good. Because, yeah, you're doing the same thing. So let's see. Let's draw the horizontal line here. Yeah, because you're probably about 1.5 right there, halfway. So 1.3, 1.4 base down. Yeah, that's what I'm saying. When you do it with your eyes versus when somebody can draw right on the target, it's a whole lot different. But essentially, it's working. You're doing everything just the same. Let me get rid of these little marks here. Yeah, so essentially we're doing the same thing. So like this one, I think this would be about where I would place if I wanted to have 2 base down and 2 base in. Would you guys agree with that? That if I wanted to have 2 base down and 2 base in, is this where I would put it? So again, I'm looking at this point and how far down I'm aligned with the 2. And this point in pretty much aligned with the 2 base in. Okay, so we're still looking at all the same things, our main point, and we're still just going vertically and horizontally to figure out how far away from here did we go on a vertical and a horizontal. Okay.
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 All right. Let's go back to sharing my screen up here. Let's see. Interpretation of power drum readings. You know what? Let me just stay right on here. Power drum readings. If I've got, let's say something like my first reading is +2, and second reading is -50, and the axis wheel is 160. Okay. Take these and put this in Rx form. So you need to know
So
that,
+2 minus 250 at 60.
yep, and that's the axis. Yeah. So we can say +2, that's my sphere, right? And the axis is set at 60. And then we're talking about the difference from +2 to a -50. Think money. Then we went -250. Okay. You might also see as sphere lines focus. That kind of means the same thing. If the sphere lines focus at +50 and the sill lines focus at -1 and the axis wheel reads 90, what's the prescription? Remember that when we do these readings, the sphere is always first, the still is always second. So that translates right back to what that is. Okay, so the sphere line, so we've got a +50 and the axis is 90. And then how far did we go from a +50 to a -1? -150. All right. Well, those should be all right, pretty good. What's the center thickness gauge measure?
Center thickness.
Yep, measure center thickness. Where do we measure the center thickness?
At the OC or the major reference point.
Very good. Yes. Yeah. So we measure the thickness right there at the OC, and it measures the center thickness or the thickness of the lens in millimeters. So being able to read that thickness gauge is important. And lens clocks, where do we put the center pin of the lens clock on the lens? Again, at the OC, right? Yeah, at the OC. Let's see. If you have a segment lens, then you want to make sure that, so there's our OC here, right? Then you want to make sure that your lens clock is held
At the distance.
yes, in the distance, and you want to make sure that it's kind of along the 180 so that you stay away from that seg, because you remember the curvature of the seg is how we get that add power. So you want to make sure that you're clocking this up here surface, the distance point, so that we can get that base curve. An ANSI application. I feel like you guys are pretty strong on ANSI. I did get a question about how much of ANSI is going to have to be memorized for the ABO. On my tests in class, you're going to, of course, be able to reference the target or the chart. I need to make sure that you know how to use the chart. On the practical ABO, you're going to be able to use the chart, but on the written, you kind of don't. The only thing that I can tell you is if you keep in mind what amount has always been allowed, like what amount of power, if I'm off by, remember I told you guys that if you're off, whenever you read something, if you're off by 1/8 of a diopter, give or take, plus or minus, if you're off by 1/8 of a diopter, then it's always going to pass, right? So it's always going to pass. If you're off by 2 degrees, that's always going to pass. What else was it? So, yeah, so if the sphere or the cylinder are off by 1/8 of a diopter, it passes. If if it's 2 degrees in the axis, it passes. Because you see down here, you know, that's kind of the kind of the smallest amount. And I guess a way to memorize this would be to memorize that anything above, remember that greater than, anything greater than 150 in the sill is going to get 2 degrees, and a quarter or less is going to get 14 degrees. And then I think a lot of people just remember that from 14 to the 2, that you go 14, 7, 5, 3. And then with these, you kind of move up in quarters, because we went basically from 0 to a quarter here, and from a quarter to 50 here, and from 50 to 75 here. And then that's your outlier. You know, you can remember that anything greater than 150. So if you just, you know, remember, oh, that 75 is there, then greater than 75 up to that 150 is allowed the 3. You just, I think, have to find things that work. I don't think they get super, super specific. I think they mainly want to just see that you can apply the tolerances, maybe that you know some of the basics, that anything that's an eighth is always going to pass. Greg, are you close by?
I am. What's
Anybody
up?
that, yeah, you took your ABO already. How much, like, with the ANSI stuff on the ABO, like, I mean, they're not trying to like trick everybody, right?
No. It's straightforward questions. They're just gonna ask, hey, you have a script. It'll give you the script, and it'll say, um, what's the ANSI tolerance for the axis, like whatever, like a quarter diopter.
So do you think they
Oh.
like, I mean, do you think they would kind of stay in, like, maybe like if it's a quarter diopter that it's 14, or if it's, you know, they give you something that's like 250 and you know it's 2? Or do they get into these little weird ones where you have to know?
Last I remember, it was that it was one end or the other of the spectrum.
Okay. See that, yeah, that's pleasant. So yeah. So either, you know, it'll be a really high powered lens and you're only allowed 2 anyway, or it'll be a low little quarter and you get the maximum 14. You know, and I think that this would help you as well too. As far as with these power breakdowns, I mean, I don't know. They're not trying to trip you up. And the other thing too is that they're not going to ask, you know what I'm saying? I mean, they only give you so many questions that they can ask you. So if, you know, maximum, you might have what, 3 or 4 questions on application of ANSI. So I wouldn't worry.
There was only 2 or 3, if I remember.
Yeah. Yeah. So, you know, I would just, you know, study the basic. I wouldn't spend too much time memorizing this entire thing if you haven't started to kind of already memorize some parts of it. Um, but I think with your experience in class, I think you're going to be fine with applying those tolerances. All right. But yeah, another one for as far as my class goes, though, because I want you to know how to use the thing and apply it really well. So you're going to have some where it'll give you, of course, what your prescription is and what you received for an order. and it'll tell you which lens type. So make sure that you stay in your lane when it comes to that one, if it's a single vision or if it's a multifocal, and that includes like flat top 28s, and then like your trifocals as well too. So your bifocal and trifocal, and progressives are just down here in their own little category. All right, so only when you get a progressive will you do that. And if it's a weird name, you might want to default on progressives if you're not too familiar with it. But I do think that if they make a mention of a progressive, it'll be a pretty common Verilux type thing. The other one is, remember that you apply to the sphere and the cylinder. So you'll do the sphere first and see if it passes. Yeah, remember it was like kind of like this. And we might have received a 212, a 112, and a 93, something like that. And then you can figure out, okay, well, I'm off by 12. This is how much I'm off, or off by another eighth, and I'm off by 3. And then you can determine what your tolerances are. And if this was a single vision, then I'd be up here in single vision. And remember too that we're always referencing this one in the prescription, unless it's a compensated or something like that. But you're always going back to that original what did I really want, to look up the tolerance here. So then I've got a -2 for my sphere, so that puts me in that 0 to 60. That's 0 to 60, so I'm allowed to be off by 1/3, and that would pass. So we're okay. Again, this is that shortcut. They're all those two that are off by an eighth, they're going to pass. But then I look for my sphere or my cylinder, and I got -1, so I'm in that 0 to -2. And again, I'm allowed that 13, so yes, that passes. And then when I'm looking into my axis, I want to, again, use that cylinder value. So I'm going to look up a -1, and that puts me in that greater than 75 up to 150. And I'm allowed 3. So this all passes. So remember, we get 3 passes. Everything's good. Remember, too, that if we get all the way to the end, if one thing fails, that lens fails, because this is one component of the RX. And so each one of those components needs to pass in order to pass. If it fails anywhere, then all of it fails, no matter how well. Well, that's okay. That's okay. No, can't pass it. Okay. All right. Here's your, you'll get these though, here's your prisms. So you've got, again, for single vision and progressives, your vertical prism and your horizontal. That's where we see that 1/3, that third and a millimeter. And you also see that 0.67 and the 2.5 for the PD. With progressives, it's pretty much, you only get a millimeter all the way around. And then the same kind of thing here, a third, and because this, anyway, me and ANSI disagree on this one, but anyway, just know your third and 1 millimeter and your 0.67 and 2.5, and you should be good. Oh, and most importantly, what cylinder form do we have to apply? Do we need to put these in order, the prescription and everything, in order to apply ANSI? Does it matter? Can
Minus.
we? Right, it has to be in minus. So you have to make sure that you put this in minus, because you do not apply ANSI tolerances to these up here. You don't apply that in plus cylinder form. You can go very, very wrong. All right. Nominal power formula is another one that you need to know. And you guys are familiar with the front plus the back equals the power, but these are other variables. I know I was just saying, well, that's F1, F2, and Fn. Remember also that you could see D1, D2, and Dn. Just know that this kind of makeup is, we're still saying the same thing. The front plus the back of the lens, these two curves are going to equal the power of the lens. And that's the nominal power formula, right?
Mhm.
The front, and you guys just kind of learned a little bit more where you're learning this week about base curves, but your front base curve, you're usually there that you're going to be given that amount, that information. So if our front base curve is 3 diopters, and then we have an Rx power of, let's say, -2, -1. I love that power. I don't know why, but here's that. Okay. That's our lens power. Then the question might be, what's your back curves? Okay. This formula up here, all these different versions, is the same thing, just changing of the variables. But that formula right here, you're searching for this. So you could either lay it out like that and, or you can just kind of change it up. And the way you change it up is your nominal power minus the front power gives us the back power. That way you can just solve it directly out with the variables. So if we're using this, the nominal power minus the front power equals the back power, then our nominal power, we're going to go in just for the sphere. So the nominal power is -2. That's the power that I want. Minus the front base curve, which is that +3. And the base curves are always going to be plus, or yeah, they're going to be plus, never minus. So -2 minus +3 is going to give us a -5, right? And I can check that by saying front plus the back equals the power. So +3 plus that -5 is going to end up with -2, right? So that's a way to check what we just did. All right. So to account for the still, if it's in minus cylinder form, which I forgot to tell you, make sure that these are all in minus cylinder form to help yourself out, and you can do it this way. We got a -5. That is going to create just that -2, right? This -5 with this front base curve is going to create a -2 lens power. But we need to also create that -1 sill. So we'll call that our sphere for now. So -1 still from that. So subtract those two and you get -6. Okay. And remember, we're solving for back curves, so the numbers are going to be a little bit weird. So we can translate that to, I need a -5 in one meridian, and I need a -6 in the other meridian to create this -2, -1 at axis 90. If you look at that on your series of lens crosses, okay, this guy right here is my nominal power rate. So -2 at 90, putting this on the optical cross. And then we'll go -1 from here. So I need a -3 at 180. And what else do we have? We have our front base curve. So that's our front curve here. That's a sphere. So in both meridians. And then you can see we can just kind of hop across. If we're trying to create -2 in this meridian here at 90, then we need to be creating that there. So 90 and then 180. Same thing with this one. If we're trying to create this -3 at 180, we need to make sure that we are working on creating that particular power at 180. So you can kind of just hop across at this point. So a +3 plus what is going to give us that -2. And yes, that -5 worked out. So -5 here. And you could either hop across here and say, well, the +3 plus what is going to give me -3. Or you could just know that we need to create a -1, right? In order to have a -1 in that meridian, or that in order to have a -1, we need to do a -1. So from -5 -1, we get that -6. That's just the way you see it optically on an optical cross here. But this is also the shorthand method, and it's probably the quicker method. So I would almost recommend doing this. But this is ultimately what is happening in picture form. So, yes, be able to solve it with the regular nominal power formula, and then also being able to solve for those back curves. Really important on for both of your exams. All right. And in line with that, let's talk a little bit about those front base curves. Base curves, does anybody remember the name of the formula that we use to get an approximate base curve?
Vogel's.
Very nice. So Vogel's rule is used to figure out what base curve. And there's one for plus lenses, plus powered lenses, and there's one for minus powered lenses, just two different versions of the same thing. So the plus power one is the spherical equivalent plus 6 diopters equals the base curve. Let's change that. Let's say plus base curve. And then you have one for your minus base curve, or a minus powered lens is the spherical equivalent divided by 2. Then you add the 6, and that's your minus base curve. It's not a minus base curve. I don't like that. It's minus power base curve. Yeah. Same thing. But we're talking about the power of the lens. So here's an example. So we get an RX, and let's say we have +4, +1 axis. Who cares? Okay. So what base curve would we need for this one? So we're going to take, and first things first, we're going to do our spherical equivalent. So our spherical equivalent means we take half of the sill. So we get plus 0.5, right? And then we're going to add that into there, which is going to end up with plus 450, right? So that is our spherical equivalent now. So then this is a plus powered lens. So we're going to use the plus spherical equivalent, or the plus Vogels. So we'll just plug and chug. So we got plus 450 plus a 6 equals, what's that? 950, 650, 1050, 1050. So our base curve for this one is plus 1050 base curve. Similarly, if we had -6 minus 2, axis, whatever. What's the base curve that we would use? So again, first things first, we got to figure out our spherical equivalence. So divide that by 2. And that leaves us with minus 1, which we add into that 6. And we come out with a spherical equivalent of minus 7. So now we will take that and put that, and that is a minus powered, right? You see the minus. So we're going to use the minus lens or minus powered one. So we take that spherical equivalent and we're going to again divide it by 2 and then add the 6. And what do we get? So what, 7, what, 350? 7 plus 6, 350 plus 6. 9, that's not right. I did my math wrong. 7 divided by 2 is minus 350 plus the 6, and we come up with plus 250 for the base curve. Okay? Does everybody feel okay about the Vogel's rule?
I just wanted to say, so for spherical equivalent, we're always just going to divide by 2. And what we get, we add it to the sphere.
Correct.
Okay, thanks.
Yep. Yeah, and it will always go right into being, yep, always. Yeah, and the minus 1, I talked a little bit about it in class, but this one feels the weirdest when you're doing it for minus lenses because you literally just got done dividing by 2. So it feels like you're doing it twice, but you have to because the spherical equivalent is divided by 2. So yeah, it feels weird, but yeah, you are still half of that. You're going to divide that by 2, and you come up with your minus 1, and then you add that in there, and then this becomes your spherical equivalent, right? But that's what you're going to use in here, and then turn around and divide it by 2 again. If you think about it, though, if you didn't, then we're going to quickly go below into minus, and a base curve is never minus unless it's a very extreme power. This is not considered an extreme power. But if you literally took minus 7 and you forgot to divide it by 2, then you subtract the 6, you get a minus 1, right? So minus 7 plus 6, yeah. And if you get minus, it's wrong. Anytime you get minus. So just remember, you got to make sure that no matter how weird it feels, that you do the divide that spherical equivalent by 2 again. All right. Using base curve charts, before we go to that one, calculating the refractive power of, so a lens clock, right? The lens clock is used and it put it on the lens and it says that the lens clock reads, or lens clock reading is +4. Okay, so if the lens clock reads +4, then you might be asked what your refractive power of that surface is. And remember the refractive power, this has to do with the index of refraction. Jeopardy quiz, does anybody remember what the index material that the lens clocks are calibrated to?
153.
153. Very good. And that's pretty important because this is a part of this refractive power formula. Basically, you've got that 153, that's the lens clock. The lens clock is reading, if it stamps this 4 and it says, oh, that's a 4 curve, Well, the lens is only really behaving like a 4 if it's a 153 index. And what's the only lens that we have currently in use right now that is a 153 index?
Trivex.
Mm-hmm. So let's see. So we've got that. So if that's a Trivex lens, then that's great. But what happens when it's a 174 index? Well, there's a formula for that, of course, right, Mary? So it's index minus 1 over 0.53 times the power of the surface that you just clocked. So we're going to say the clocked surface. The clocked power will give us the refractive power. Okay. And how do you equate all of that? This is our index that we're trying to use, right? So we want to know. So we want to know what the refractive power is in this surface. So we just take index minus 1. That basically just shortens to 1.74 minus 1, which ends up giving us 0.74. And the same with this on the bottom, it's actually 1.53, which is this index of the clock minus 1, and it ends up being 0.53. I just kind of skip right over to just drop the ones off of both of them and start multiplying. So 0.53 or 0.74 divided by 0.53. When you put that into your calculator, it gives you a conversion factor. So 0.74 divided by 0.5 gives us the conversion factor of, did anybody else doing this or y'all lost interest? 1.48. Is that what, anybody else do this? 1.74.
I did 0.74 divided by 0.53 and I got 1.39.
That's what I got, 1.396. Thanks. Good. I thought that was a little excessive. Right, so that's my conversion factor. You don't really usually need to write that down, but keep that in your calculator and then multiply that by the power of the lens clock reading. So multiply that by 4, and you end up with 5.58.
584.
Yeah, and so that the lens here, basically this 4 diopter curve in this 174 material is acting like more like a 558 as far as power. And so that's what allows, when you're working, you're always saying, oh, well, you can go with a higher index, it'll be thinner and lighter weight, thinner and flatter and lighter weight. Not always lighter weight, but thinner and flatter, definitely, yes. That's because of that refractive power of the surface, of the material itself, not the surface, but of the material itself. So we can kind of go the opposite way. If it gives us 1.58 diopters of power over this 4, right? Then we can actually flatten this 4 curve by 1.58 and we'll still end up effectively with a 4 diopter lens. So that's how they make them thinner. All you need to be able to do is take that lens clock reading and compare it to the index of the material. So you'll need to be able to do that part. Okay. So index minus 1 over that 0.53, and then multiply it by that clocked power, and you're good to go.
I wanted to say real quick,
Okay.
you're going to send us links to these videos, right? Because I'm probably going to rewatch this before I take my ABO for certain things.
Okay. Yes, I am. I've got to see how the video, like how I get a hold of it. It might take me a little while, but yeah, you will get it, and I'll try to get it to you. I'm hoping to get it to you before the end of the evening. If I can get it, depending on how much involved it is.
Okay, thank you. Because I'm gonna, try to do my best on your finals and stuff. But before I take my ABO, I'll probably just rewatch things in case I forget things. So thank you.
You're welcome. Not a problem. All right. I think I kind of covered it all. Was there anything that I didn't cover? We did skip over using the base curve selection chart, so let me pull that up real quick. Have that here. I switch over. It's been a long day, hasn't it? Like, and she kept us the entire time. It's a lot of info, you know?
It's a shorter day than it would have been if we drove to class.
Well,
Yep.
amen to that. I'll give you that one.
Been a
Let's
beautiful
see.
day.
And I get to be cuddled up with my doggy, so I'll take it.
Right on. All right. Base curves is in here. Nope, not that one. Yeah, to read base curve charts, this is going to be kind of, let's use this one. I did give you guys direct feedback. I drew on this thing, right? Did anybody have a chance to look at that, or was that in my other lab class?
That you did what with that?
I drew on this and to give feedback on the grading of this one.
Oh, I don't remember if I looked at my feedback. I'll tell you in just a moment.
I don't know, but I know that our worksheet that's due this week, you have it in there. Like it's a chart.
Oh, okay. So you haven't done this yet. Oh,
I'm
okay.
looking at it right now.
Okay.
I thought I was crazy because I was like, I don't remember doing that.
Okay, well, there's I teach the certificate students, and so they had this lesson too, and in it I went on and I drew and explained. I think I did that for you, Greg, because I think you submitted yours already. But anyway, okay, so looking at base curve charts, these are for each individual type of lens. So this is just for this Kodak Precise Short. It's a type of progressive, and it's only in their 167. So they would have a whole nother chart for a whole nother material. If it's a CR39, they're going to have a whole different chart, kind of using the same layout, but these base curve values may kind of change. So there's a base curve chart for each and every lens that is designed, and for the each and individual material. So this one is for the high index 167. But they all work essentially the same. You're given a prescription, and over on the left-hand side here, this is where you'll find your sphere powers. Okay. And along the top here, you see this kind of cylinder thing. I don't know if I can zoom in. Is that that's as close as I can get, but you see cylinder written right up here. So all of these are the increasing cylinder values that you can use. You see that it stops at a -5. So anything beyond a -5, the manufacturer of this lens would prefer you not to use this. So you may get like the lab saying, oh, that's out of range. So this is the power range that's allowed for this particular lens in the cylinder. Okay. Down along the sides here are our sphere values. So you see we've got plano right here, plano plus quarter, 50, and all the way up to a 6. So this lens goes up to a +6 sphere, allows that. But anything beyond that, you might need to select a different lens because it's out of kind of out of the realm for this lens. And then you see we go the opposite direction here. And of course, we get a lot more minus. Plus are a little bit more particular because of that center thickness. So you usually see less options in the plus than you do with the minus. But this lens actually goes up to a minus 1325. Inside of here, you see where your base curves are. You see one base curve, and then this one says that you could use a 1 or a 2, and then this is a 2 base curve. You could use a 2 or a 450, 450, 450 or 5, 5, and it goes up to a 750 base curve up here. So how you use this chart, I hope it's burned in your memory. I'm not switching back, but let's say we had a -2, -4. Okay, so -2, -4, and we don't care what the axis is. It could be anything. So let's just make one. We don't even need one. So I've got a -2, -4 with a 90. So -2 is my sphere. So I'm going to find my -2 here in the sphere meridian, or yeah, in the sphere. So here's my -2. And then I've got a -4 in the still. So I would go up to -4. And then I just follow and track that down. So here's right around here, right where my mouse is. You can see right about here is where I fall because I'm aligned up with that -2 for the sphere. These are just repeated over here in case you have a higher sill. And I'm lined up with the -4. So we're falling in this blue area in here, which means, so for a -2, -4 lens, I would want to select a 450 base. Does that make sense? I'm hoping it does. So let's say I have
Yes, I understand that one.
okay, good. So if I have a +250 and a -150 sill, so +250 right there, heading out, and that aligns up with that 150. So 250 and 150, I'm right about here, and I'm in this yellow range, and so my base curve would be 550.
So the top is cylinder, and then the sides are spheres.
Correct, correct. And if you just, yeah, this one's marked with cylinder right there. It's hard to see. Most targets are going to have your sphere and cylinder marked. See, like this one, this is another base curve chart, and you see prescription sphere power, and then they say minus cylinder power. So a lot of times they'll mark it. But
Okay.
one thing you can always know, they're going to offer you more sphere variation than they will cylinder variation. And this one's a little confusing because they put that sphere there. I think that that is kind of a placeholder so that if you have a +5 sphere, then this is your block. If you have a +5 and a -1/4 in the cylinder, then this is the block. If you have a +5 and a -50 or -75, -1, so it kind of goes up like that. But yeah, so usually that sphere is going to be on the left side and the cylinder will be on the top. A lot of times they're marked. On this particular one, it just lists the cylinder. Let's see, what did it do over here? Yeah, over here on this one, you see you got the sphere marked here. So it's saying all these are the sphere powers and these are the cylinders. But again, the same thing. You go from 0 to -6 in the sills here. This lens is from a +8 down to a -10. So anything beyond that would kind of be out of that range. And then these are just marked the same way. It's just not colored. I think this is the one that's in the book. But you've got your -1, and then this is the range in here for the 225. There's your 275, 225. and on up to 11.
I had
And
a
you,
question real quick
okay,
on the other chart.
yeah,
For our worksheet, it
yeah.
shows the chart and it asks our questions. I think there's like five, there is five of them. But
Mm-hmm.
like number one says +6 minus 250 at 162. So we're going to do the same thing you just did. We're just going to look at the chart. We don't have to do any other math, right? We just look at the
The
chart.
only math you might have to do the chart would be to change it, transpose it into minus cylinder form. But other than that, no, there's no math at all.
Okay, so we might have to if it's in plus.
Yes, if it's in plus, you absolutely have to change it. All of them are all minus cylinder. All these charts are always minus cylinder.
Okay, thanks.
You're welcome. There is one other little thing in there. It talks about because one of these lenses ends up landing in this kind of in between zone. You see where this one says 550 to 750, 450 to 550, or 2 or 450, and 1 and 2. So you've got that kind of in between zone, right? Between, well, it didn't fall in the 2 and it didn't fall in the 1. So you get an option. And these little lines here are actually, that one's a single line for a reason, and this one is a double line for a reason. Okay. If you look up at the top, it tells you what it is. And I'm going to tell you how to interpret that as well, too. So this, if it's a single line, it says right here, best peripheral optics. So you can shorten that to basically just best optics. Okay. So, okay. And then the other one has the double line here, and this one's for better cosmetics. So do you want to err on the side of, because you get to choose your base, your base curve. Whenever you land in these ones where it says 550 or 750 base, same thing with the 450 or a 550 base. When you land in those in between areas, for this one, it'd be a plus 325 up to plus 375. And then, of course, with all these cylinder values. But when you land there, if you want better optics, then you want to head towards the single line. So in that case, if we were in here and I get to choose between these two base curves, and I wanted to do better optics, then I would go towards the single line. And that would let me know that I need to choose a 550 if I'm more concerned with the optics. Okay. And if you see the double line here, yeah, it looks like a solid gray line, but I think that's just the distortion. But yeah. Anyway, so this one's the double line right here. And if I wanted to go with a better cosmetic appearance, then it's telling me that I would go with a 750. Let's see this one right here. So if I was in this range right in here between this 650 and 5, right? If I fall anywhere in this light colored area, I get to choose between a 2 or a 450 base. And so if I want a single line, which was, remember, that's my better peripheral optics. So if I want better optics in this, I would choose that 2 base. And if I was more concerned with the cosmetics, I would choose the double line and go with a 450 base. Does that make sense how you read that?
Yes, I see.
Okay, and it is up at the top. Depending on the brand and the manufacturer, you may have this option, but just, getting comfortable with reading what those charts say. Just looking at them and finding the information that you're looking for. The last thing I want to point out is this area right down here. Of course, anything that goes over these power ranges where we have that 1325, Once we get into 1350, 1375, 14, 15, those wearers unfortunately can no longer wear this lens and would need a different index or a different lens style completely altogether. On this chart, they do show, because they cover up to a -5 seal, but not in a lot of these higher powered lenses. Okay. So yeah, if it just so happened to be a 10 diopter sphere with a 5 diopter seal, that's just too much for this lens to handle. If you look at the two power meridians, we've got a -10 and a -15, and that -15 is just too much. So the higher the seal goes, the less you get to use this lens. You probably need to change to a different material, probably, believe it or not, plastic. This right here, and it does tell you when you're reading it what you're looking for here, but this kind of illustrates some of the points that you're learning about in that lens curve one, the lens curve lesson. But this is kind of showing you, this is a traditional lens, and this is this fancy freeform lens. And now this is marketing because look, they're like, oh, our lens is perfect. But I want to show you this. If you see this green, and there's a little thing down here that shows it, but this green means there's like a low power area, error. So AKA, think about aberrations. So this is less aberration to greatest amount of aberration, okay? And it slowly compounds and increases in aberration. When you're choosing your different, well, okay, no. So when you're reading this, you see this green right here. So they're saying that's the least amount of aberration. If this person has a +4 sphere, then this lens, this 680 base curve is perfect for them. But once we start to increase that seal value, so you see these seals here, the more that seal value increases, the more we head into a more aberrated lens. Okay, so, and that aberration is less, you know what? We're running out of time. But anyway, this just kind of helps to illustrate the kind of how aberration does impact the lens. We will talk more about this at a later time. And you won't be going over that on the final, so I'm going to wrap that part of that up. One thing I do want to point out, this will be for the ABO and the final. Let's see. Find. She's not in here. I think she's in here. Okay, pulling up. All right, the Abbe value. When you get to reading about this, Abbe value is a little bit weird because it doesn't seem intuitive. Abbe value starts kind of up at 0. So you think of, I'm sorry, Abbe value starts at 60, right? So you think of, when you think it goes from 60 to 0. When you think of 60, think no aberration. Okay. As you move closer to 0, we keep increasing the aberration, 0 being complete aberration. And you can't wear a lens like that. That would be like wearing a diamond. That would be too much aberration. So 60 and higher numbers are good, okay? Versus lower, so the lower the Abbe, the more aberration increases. So you can see right here, you see these Abbe values and, kind of the the top notch, the creme de la creme, the least aberrated are the ones on the top. And then as you move down and as we kind of almost increase in index, especially in the plastic varieties, as you increase in index, that aberration tends to increase as well. But there isn't really, it's not 100%, doesn't work exactly like that, but it does just kind of generally. So just remember that the kind of the higher Abbe value is a good thing. Okay, higher Abbe, less chromatic aberration, lower Abbe, more chromatic aberration. Let's see. Yeah. And then you've got your distortions, history of lenses. I did want to point this out. You know how in Vogels we add 6? We add 6 to the curvature that for the base, we take, the spherical equivalent plus 6 or the spherical equivalent divided by 2 plus 6. This is kind of where that 6 diopters coming from. Back when they kind of designed the meniscus lens, when they designed that lens, they were kind of all about the 6 diopters. A 6 diopter curve was just the best. And either a 6 diopter curve on the front of the lens or a 6 diopter curve on the back of the lens. And, it would be a good optical match for that. But so that's where that 6 comes from. So you just see it a lot. You'll see that 6 frequently used kind of as a standard line. When we're looking at base curves, plano, if you look at if you do Vogels with a plano powered lens, you end up with a 6 base curve. So right here you see plano or no power, you can think, oh, that's going to be on a 6 base curve according to Vogels. And then as that plus power increases, the base curve steepens. You see how, because we're getting more of that con, or that, that plus shape there. So as plus power increases, that base curve steepens. So it goes above 6, if you will. So like to a +8 or something. Plus, it could be anything above 6. And then when you have a flatter base curve or when you have minus power lens, the more minus power, the flatter this base curve gets. So it gets shaped more like that. You see that flat front surface almost. So the front gets real flat. And so it might go below 6, right? So 6 was plano and then that minus, and we go below 6. So in that kind of line of thinking, if I told you I have a +7 base curve lens, what could you assume was the power? Is it a plus powered lens or a minus powered lens? If I have a +7 base curve.
Plus.
Right, very good. If I have a +2 base curve, is that a plus or a minus powered lens?
Minus.
Yep. Okay. So you can see, yeah, that relationship there. All right, and these are just showing you examples of that being worked out. All right. We did all of this. There's that index of refraction formula. All right. All right, so that is, I went over everything I wanted to go over. We are right at the 2:56 marker, so I'm going to go ahead and let y'all go. If anybody has any questions, must stop sharing, stop the video. But if anybody has any questions about anything, feel free to hang out. Bella, can we just calm it down a little bit? If anybody has any questions, you can just stay on, but if or whatever, but you can also head on out. Good luck, and I will see you next week on Tuesday in class
Thank you.
for your final.
Thank you.
You're welcome.
Do we have
Yeah.
a certain amount of time, Tracy, for the test?
Um, that for the you get 2 hours for the lensometry. I can't remember what it is for 132. If I can find that out. But I'm sure you do have a certain amount of time.
Okay, no worries. I just wanted to prepare myself. That's all.
Yeah, 90 minutes. It's 50 questions though, so you'll have plenty of time.
Oh yeah, that's a lot of time.
Yeah.
Thank you.
You're welcome. Have a
Yes,
good
thank
one.
See you next week. Bye.
See you next
too.
week.
See you next week.
you.
Bye.
I have one question. I'm sorry.
No, you're
I
fine.
feel
You
so
never
bad.
ever need to apologize for asking a question.
I know that I should know this, but I don't remember, so I'm hoping you can tell me.
Okay.
When the base curve is specified by the optician, ANSI tolerances allow up to blank D of variance. I
Mhm.
don't know.
That one you will find it on your ANSI on the ANSI tolerance chart. Do you have that with you?
It's somewhere in here. Yeah, so it's on there.
It is. It's on there and it's down at the bottom.
So
it's in the little miscellaneous category.
Okay, thank you.
You
We
are
have
welcome.
to bring our computer, right? For
Mhm.
finals. And we get to bring our calculator, right?
Yep.
Alrighty, well that's all I had. Thank you.
All right, you're welcome. Have a good one, Mary.
All right, bye guys.
Bye.
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 I have a question.
Okay.
You say you have to bring a laptop next week, right?
Mm-hmm.
Oh, I don't have a laptop, so what can I do?
We'll either set you up with one. We have some in the lab. So don't worry about it.
All right, good.
If you need
All
me
right.
to bring one, I can bring another one. I have two. So
It doesn't matter. You say you have some in the laptop, right? In the lab, right?
Yeah, but is yours better?
yeah.
Probably is. I would probably go with his. The school one is going to be a little bit more outdated.
All right, yeah, that's fine. I appreciate it, Greg.
But Greg,
Yeah.
if you forget it, yeah, Carlos, I still got you. And if not, we got
Yeah.
computers and stuff. I'll put you on something that'll work.
Yeah, I appreciate it.
Not a problem.
All right. All right, y'all. See you next week.
All right, see you then.
See ya.
Bye.
Bye.
Tracy,
Sean.
how's it going?
It's going good. Are you feeling better?
I'm okay. I feel like it's out of my system. It's been a rough
Yeah.
morning, but
Yeah.
we'll
It
get
takes
through.
a toll.
My boss is a dick, so I was just
Yeah.
telling him he's a dick, so there was that.
Yeah.
My segmented lenses, I tried
Hmm.
to submit it, but I can't. And then my project 5 for the center thickness gauge and lens clocks, it also wasn't letting me submit it. Do you want me to email those to you, or
No, just hold up because I'm going through and trying to work on grading. I've got another class to plan for tomorrow and Thursday, and then this video to get up. But can you just hang on for
I certainly can.
until maybe up to Friday? I'll try to get it done as soon as possible because I definitely want to get in and start getting stuff, the last stuff graded in there. So just keep an eye out for an email from me that says I'm opening them up. So you said center thickness and lens clocks, and what else was the other one? Segs?
Yep.
Okay. All right, because there's probably other people that might have missed it too. All right. Anything else?
No, I'm just going through and doing all the homework that I've missed, making sure I've got that done, did all my tests and stuff, and doing the UV one right now and stuff like that. Oh, I didn't talk for most of this one because it wasn't letting me, and then I had to leave and then try to join back, and that's finally how it let me.
Okay.
I love
I
how you
understand. I just never know if everybody's like, "Oh my God, why is she still talking about this?" You know what I mean? It's just, and then I'm like, "Am I getting?" I mean, because I can teach you anything you want to know. I just want to make sure it's beneficial, not waste anybody's time.
Yeah, I feel like Greg sometimes, where like I guess I try to sit back and like let other people answer, so that
Yeah.
they can get along with it. Because if I answer everything for everybody, it's not going to like help them know it.
Help them learn or
Yeah. Yeah. And it's a fine line because then there's me